Hi. So for part B of this question, we're told the force of magnitude 4 newtons is removed. Find the acceleration of P down the plane. Okay, so again, the first thing I'd recommend you to do, like in any other maths question, is to draw a nice big schematic of the question, okay? And this time it's going to be without that 4 Newton force because we've been told in the question it's been removed. Okay, so if you're in the exam as well, just another thing to note, you can simply ask for extra paper and then you can attach it to your answer booklet at the end. It's completely fine. So we know that there's going to be some acceleration down the plane. So I'm just going to put a green arrow there to show that there's acceleration and to show its direction. Okay, so I'm going to start to label in all of my forces. Okay, I'm going to draw in all of my forces. I'm going to draw a free body diagram. And to keep consistency, I'm going to draw all of the forces extending out of the particle. Okay, so the weight always acts vertically downwards. And we know the mass is 0.5 kilograms. So the weight is therefore 0.5 g newtons. Okay, so now I'm going to resolve the weight into its constituent components, perpendicular and parallel to the slope. Okay. So I know that part of the weight pulls the particle into the slope and part of it is pulling it down the slope, okay? So this angle is alpha, and you can prove that in your own time. So I know the force that includes alpha is cos, so this force is 0.5 g cos alpha newtons, okay? So I know the force that does not include the angle is sine, so this force is therefore 0.5 g sine alpha newtons. Okay, so I also know the particle is not falling into the slope, so there must be a force which is pushing it in this direction, keeping it on the slope, and that is the normal reaction, and that is acting perpendicular to the slope, and it's got magnitude r newtons. Okay, and again the slope is rough, so that indicates that there is friction involved. Okay, so friction always opposes motion, and the motion is down the slope, so friction will be therefore acting up the slope. Force of magnitude F newtons there, that's the frictional force, okay? So now I finished my free body diagram, what I can do is I can start to resolve, okay? So first of all, I'm going to resolve in this direction, okay? What this means is that I'm going to take all forces acting in this direction to be positive, and all forces in the other direction will therefore consequently be negative. Okay, now it doesn't matter what way you resolve, I've just chosen to resolve this way. So we get r acting in the positive direction, and we get minus 0.5 g cos alpha. Okay, we're applying Newton's second law of motion, so we equate this to mass times by acceleration. We know the acceleration is 0. It is not accelerating in this plane, it is accelerating in this plane. Okay, so we equate this to 0, the acceleration is 0. Okay, so now if I add 0.5 g cos alpha on both sides, I'm trying to rearrange for r, we get r is equal to 0.5 g cos alpha. Okay, what I'm going to do is I'm going to label this equation 1. Okay, so now the second thing that I'm going to do is I'm going to resolve down the slope. Okay, I'm going to resolve down the slope, and again what this means is I'm taking all forces that are acting down the slope to be positive, so all forces acting up the slope are therefore going to be negative. Okay, and again it doesn't matter what way you resolve, you could resolve up the slope, but you would just get a value of acceleration which is negative, and all that is showing is that the acceleration is acting down the slope, okay, because you've taken up to be positive and the acceleration is acting down the slope. So as a rule of thumb, I would probably always resolve in the direction of the acceleration, okay, so we don't have to deal with negative or positive signs or whatever at the end. So we have 0.5 g sine alpha acting down the slope minus that frictional force which is acting up the slope, and we equate this again because we're using Newton's second law of motion. We equate this to mass times acceleration, and we know the mass is 0.5 kilograms and we do not know the acceleration, so we just leave it as a. Okay, so now in my next line of working out, what I'm going to do is I'm going to divide both sides by 0.5. Okay, 0.5 g sine alpha minus. Now, what I'm going to do here is substitute mu r as f. Okay, Q layer 1. You should be familiar with this relationship here. F equals mu r. Okay, so the frictional force is simply equal to the coefficient of friction times by that normal reaction force. Okay, so I'm just going to substitute mu r instead of f. Okay, so I'm going to write mu r instead of f there. Okay, and like I said before, we're dividing by 0.5 here in order to get a by itself. Okay, now I can just label this equation 2, and what we're going to do is we're going to substitute equation 1 into equation 2 in order to calculate the acceleration. Okay, so you'll get 0.5 g sine alpha minus. Now we know what mu is. Okay, so from the previous question we've calculated the value of mu to be 0.207 to 3 decimal places. I've just written this in blue because I want you to be aware of the fact that you should not type in 0.207 on your calculator. Okay, what you should do is type in the ANS button. Okay, so you press your shift button, and then the answer button in order to obtain the exact value. Okay, or you can store this answer in your calculator and then use it. Okay, so it's not actually 0.207, it's 0.207, and it continues. Okay, so I'm just going to write that so you know to use the exact value, not 0.27 as it is. Okay, and this mu is being multiplied by r, and we know r is 0.5 g cos alpha. Okay, so we have 0.5 g cos alpha in brackets there. Okay, and this is all being divided by 0.5. Okay. Okay, and now we're nearly done. All we can do now is substitute values of exact values of sine alpha and cos alpha into our equation. Okay, so I know that sine alpha from the previous question, again, we know we calculated the exact value of sine alpha to be 3/5. So I'm just going to substitute 3/5 into there. And then I know the exact value of cos alpha as well is 4/5. Okay, so I can just substitute that in to there. Okay. Okay, and when you put this into your calculator, you should get a value of A being 3.76 meters per second, okay? And it is positive, so it means it's acting down the slope because we've taken this direction to be positive, okay? So we can say down the slope. And I haven't rounded this. This is what the calculator has given me. So I've left it how the calculator display has given it. Okay, to 2 decimal places. Okay, so I hope you followed. Thank you very much.